Now, one of the questions I'll be asking is where will I use RISC-V assembly, like practical applications? Now, the first place you will be using RISC-V assembly is in CPU initialization. So if you are doing tasks like CPU initialization, where you need to set up the main CPU registers, the stack, RAM, and other peripherals on board a RISC-V microcontroller or CPU, then RISC-V assembly will serve you well. Another place is if you are designing operating systems or real-time operating systems, and you work very closely at the operating system level. So if you are designing operating systems and you need to do things like hash handling, context switching, then RISC-V assembly becomes a valuable skill to have in your tool belt, especially if you're writing embedded software and you have to design your own operating system or modify an existing operating system. The third place you'll need to use a RISC-V assembly language programming skills is in working around silicon errata. Now, this is something people don't really consider, but CPUs are made from silicon wafers. And what that means is that there may be specific errata in the silicon chip or die that you may have to fix that the compiler did not account for. In such cases, knowledge of assembly and using assembly to fix the silicon issues is something you want to be able to do. Also related to silicon errata is chip-specific optimizations, because once you can work around the errata on the chip, you realize that specific implementations of a CPU sometimes has instructions that are specific for that device. An ability to use instructions and chip optimizations that the compiler didn't cater for is a good skill, especially since RISC-V compilers now are a bit behind compilers for the architectures. And the fourth place you'll really use your RISC-V assembly language knowledge, and the most important skill is the ability to read assembly code. Or even if you never have to write another line of assembly code after finishing this course, once you're doing real computer engineering or in-depth computer science, you will have to read assembly code at some point. And it's one of the most powerful things you will be able to do. If you ever have to use a debugger, or you have any reason to look at output of your programs, you kind of will have to read assembly code. And this is very important in RISC-V because it's a relatively new ISA, and you will have to do a lot of debugging and other optimizations. So you will need to learn to read RISC-V assembly. It's the most important skill set you'll have as a programmer, developer, or embedded systems engineer.